The very first thing that I actually learned in geometry is, and we start with a point.
Mm-hmm. So
So you're
point,
seeing
and
my
that's
screen.
really
You're seeing my
off.
screen, right? Is that
Yeah,
okay? And I think of a point as a place in space.
a place in space. All right, and it rhymes. It's perfect.
Yeah. Now, if you extended a point, you would get a line segment.
Line segment. And so when there's a line segment, does that mean it's moving on forever? Or is it just a line to a line? Or I mean a point to a point.
It is currently a point to a point. So you and I, and basically everyone else that isn't in a geometry class, and even in class, we use the two words line and line segment improperly.
Mm-hmm.
A line, a line extends forever.
All right.
Okay, and but you and I, like you play tennis, you watch
Mhm.
sports. They talk about the line, sideline, the end line, the line, touch the line. They really mean line segment. So
Okay.
so a line segment is fixed at both ends.
Fixed at both ends.
It's like held at both ends by a point.
All right. So it's the line in between the 2 points.
No, it is a line segment. And that's the reason I have to correct you is because geometry is much more specific with language, and you
Mm-hmm.
get into proofs and other things. And there's a lot of funny stuff on, like, on social media. It's like prove that that's a triangle. It's like, well, yeah, it's a triangle. I don't, it so problem is you can't do that in this
Yeah.
class. And that's the nuanced part of this.
Mhm.
This is a line segment, not a line. Okay. Here is a line. It's gonna look really similar. Okay. But it's not the same. It has these little arrows at the end. It extends past the 2 points. A
Uh-huh.
line extends forever, but we use that wrong. We use it wrongly in everyday life. Okay. We say the line going down the center of the road, does it extend forever? No, of course not. It stops at some point. Or
Oh, so then technically like the lanes on a road would be a line segment.
yes, exactly. Because
Oh.
it doesn't, look, if you look at, if and it's such a, it's for lack of a better word, it's kind of like a Karen thing where if you correct people, like, no, 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 it's a line segment, like what? Like they wouldn't even understand.
Yeah, I
um
mean, I wouldn't have gotten that until right now.
right. So there's actually like a bunch of other things like this that we sort of improperly um use. So like I saw this today in a AP statistics class. Someone posted, 1 in 500 have red hair and blue eyes or something.
Uh-huh.
I have no idea if this is even true. And they
Yeah.
said this is a stat right here, 1 in 500, and it's actually not. It's actually what's called a ratio.
Mhm.
Okay. Now, are they wrong to call this a probability? No, but they're like the letter of the law, they're wrong. Okay.
Mhm.
And so, I'm just going to generalize a little bit. Just maybe no, I don't know this about you, but there's certain aspects of religion that are very much like, the law says this, the law says this.
Uh-huh.
And so it's like, are we breaking the law? I mean, kind of a gray zone thing. Um,
Yeah.
Another one you kind of see is we use the words accurate and precise incorrectly. You often see two pictures. Here's a bullseye,
Mhm.
and here's the other bullseye. So that's precise. That's accurate.
All right.
This
Oh,
one's
so
this
then
one's
but
also
when
precise,
when
but
you say
but
accurate, it means
yeah,
like I have like a good shot, and then with precise, it's
right.
like I have a perfect
Like
shot.
you could be precise with your tennis, hitting it out every time. Beyond the baseline. It's like no, no, that's no good. So,
Yeah.
um, and then you get into psychology, and there's all these different, like we use these words like interchangeably. But we don't actually, we're not using the words properly. Okay.
Mhm.
And let me think of there's this is actually worth just a few minutes here.
Yeah, of course.
Oh, here, I mean, just a real simple one is the difference between a psychologist and a psychiatrist. I couldn't tell you the difference.
I
Okay.
can either.
Right. But one is like a medical, one is a researcher, and one is like a therapist. Um, so it's you got to be careful here, and that's what we're
Yeah.
trying to talk about here. Like it's a line segment, and this is a line. Okay. And
Mhm.
you have to be prepared to talk about them. You have to use the correct language when you're talking about them. So if you mean something that extends forever in both directions, that's a line.
Okay.
Now, in terms of like how these are labeled, let me jump into that here. So a point is generally labeled with a single letter. A line segment, two letters with a bar on top. A line, same two letters, but now it's got the arrows on both ends.
Mhm.
Okay, and that moves us into what are called now rays. So rays are kind of like a combination of these. So a ray starts, it has a starting point, and then it extends forever in one direction. Okay, and this is the way we would describe this. I'm going to actually just move this over and then show you, is we would say it's A to B, meaning it starts at A and goes to B.
Mhm.
You are
Oh, so
not,
in
and
one
you can,
direction forever.
yeah, now you cannot interchange these. So like B to A means this. I'll just draw it in a totally different direction just for that. It means it
Yeah.
starts at B and goes through A.
Okay. So it can, so the line will have a starting point and raise.
Yes, they have a known starting point. That's very important. And that starting point is the first one.
Mhm. Okay.
And this is so this is where it can get very confusing because I can say do rays AB and AC, do these combine to make a line? A line.
Um,
And let me give you two possibilities so you can see this. Here's A, here's B, here's C, and then here's another one. A, B, and C. So see how in case one, AB is a ray, but it also goes through C. AC is a ray, but it also goes through B, but they're going in the same direction.
uh-huh.
But in the second picture, here's AB, that's okay. And then AC goes left and it makes a line. But there's even yet a third possibility. AB, and there's C. Now it makes an angle.
Uh-huh.
And why do I bring this up? Because you're going to get questions in geometry that are like always, sometimes, and never true.
Mhm. So would that third one be like a never true?
This is the answer to this question is that it's sometimes true.
Okay. And then I guess that could be seen in like certain shapes, right?
Yeah, and you have to like, well, this is what's hard for most students is you have to draw these, and it's like, how do you draw something you've never
Seen.
seen? It's like asking you to look up a word in a dictionary that you don't know how to spell because you don't know where to look.
Yeah.
You have no starting point. So that is so there's really this divide, and I'm kind of going off tangentially. There's kind of this divide in geometry. There's problems where you're given the figure, and then there's those where you have to draw the figure.
Mhm.
And the second are way harder for almost every student ever. Okay, so let's kind of re-summarize here again. points live in one dimensional space. Okay. Lines, line segments, rays. Okay. And even angles to some extent, they live in two-dimensional space.
All right.
So what I mean by that is if you're in this computer screen, this monitor, you're seeing this two-dimensional space. Let's say you are there, Zach, and I live here. Okay. You can move up, down, left, right.
Mm-hmm.
Let's assume you can't move diagonally for the moment, although you could. Okay.
Yeah.
That's all you can do. You cannot jump out of the screen.
All right. So then.
So think about the world that you and I live in right now. Is it two-dimensional?
No, it's not.
No, it's not. But there's actually this really interesting book, which you probably don't have time to read, but it's called Flatland. It's actually about these things that live in two-dimensional space. It's really weird. Think about like the Earth being flat,
Mm-hmm.
which is ridiculous now, but we didn't know
I
any
mean,
better.
yeah, back then people thought it.
Yeah, they thought, well, what happens? Well, I don't know. um, so then you're like, well, what is three-dimensional space? Well, it's the world we live in, and that's where we talk about what are called planes. I'm not talking about airplanes. I'm talking about three-dimensional space, which it's hard to draw in two-dimensional space, but you can sort of see it here.
Yeah, like
the plane extends forever in all the directions, and then you can obviously go up or down. And you and I live in three-dimensional space, or I guess some people argue it's four-dimensional because of time, but we do that. So what's really interesting is that you can talk about things in terms of what different dimensions. So for example, here, let me draw something. So here's a plane. Okay. And then I'm going to draw another plane down here.
Are they overlapping?
Yes. So there's some distance between them. So the planes are, and if I was in front of you right now, I would show you two sheets of paper that are separated by a distance. They all extend out forever, right?
Yeah.
Plane extends out forever. So planes are three-dimensional. Now here's a line. Actually, let me do this first. So you can draw a line, and this will extend forever, up, and then it goes down. Do you see how it hits both planes? We'll call that point A and point B. And it extends forever. Let me see if I can get this a little more. Okay. Now you can also have a line that's on, or let's do a line segment. B to C is a line segment. So BC is a line segment, and it's on that plane. And then, but there's line AB. Now here's point D, and we're going to add in a new terminology here. B, C, and D are what are called collinear.
All right.
Collinear is a new definition. So some teachers really emphasize this. They maybe even the back of your book has a glossary. If you've never looked at your glossary, I understand. It's not super exciting, but they'll have a glossary where they'll define some of these. They're more common in like a history book or an English book, but in geometry is very different. It will have a definition maybe, but collinear means same line. Okay, they have to be on the same line. But here's point. Let me draw another point. Here's point E. Is it collinear with B, C, and D? No.
No, it's not touching them.
Yeah. Now, here's a point down here. We'll call that F. A, B, and F are collinear because they're on the same line.
Yeah. All right.
Okay. And this is where it's challenging again. So I've drawn the picture, and we can sort of do this. I could give this to universe. I could say, draw some. Well, let me actually add one more thing here. B, E, C, and D are what are called coplanar. That means they're on the same plane.
Coplanar on the same plane.
Yes.
All right.
And not to try to blow your mind here, but you can actually draw planes that intersect. Let me try and do that here because this is worth doing. So because I think you do see this at some point early on in the course. Here's a plane, but you can also hit this plane with another plane. Let me see if I can even do this. So that they intersect. Now this thing goes forever this way, but they intersect right there. And it's really hard to see, but they do intersect.
Mhm.
And so they ask you these sort of obscure questions, which is like, what does a plane intersecting a plane look like? Okay, and the answer is it's a line.
So a line, and that moves on infinitely.
Yes, because planes move on infinitely in each direction.
All right.
And if
Is there a thing as a collinear plane?
no, it's either coplanar or collinear.
Okay, so there are like planes that have an ending.
No, no.
Oh, so they
Planes,
go on forever.
planes extend forever. Yeah,
Okay.
but they're drawn. See, that's the thing. It's really frustrating. Is they're drawn as if they don't.
Yeah.
Okay,
I guess that would be pretty hard to figure out.
it's really hard. Because they do. So you don't spend a ton of time in 3 dimensions in this course, but it's worth understanding that this does happen. So that's kind of you're like, okay, like what is this geometry all about? Well, you start with this sort of terminology, and then you are asked to do things like I see in your book there. Let me pull up a problem or two. To get you to so I'm just going to pull up a problem here. This is one of those that you have to draw. It's kind of obscure. So it says, name the diagonals of a pentagon A, B, C, D, E. So notice that you don't have a drawing, so you got to make it. It doesn't tell you what type. Pentagon has 5 sides. So as long as you get something with 5 sides. And then the thing that they probably haven't emphasized enough is that this is like a path.
Mm-hmm.
So you start at A. If you ever looked at a map, which I know we do everything electronically now, but if you used to old timey maps, you'd have a starting point, A and B and C and D and E.
Yeah.
You don't just arbitrarily set these. You have to choose them either clockwise or counterclockwise, however you see fit.
Mm-hmm. So it has to be like in order, sort of.
Exactly, because you can get some weird, like if I said quadrilateral A B C D. I mean, you could you could really get some weird things. You could say, oh, it's A, that's C, that's B, that's D, and then we're all off. So you got to do it in order.
All right.
Okay, now the diagonals, again, this is probably very unclear. A diagonal is something that does not connect what's called an adjacent vertice. So like A to D, let me do it in a different color. A to D is a diagonal.
A to D is a diagonal.
And so is E to B. And so is E to C. And so is C to A. And so is B to D. Now, what do you notice about the shape that's inside here?
It's like a star.
I'm talking about this one right here.
Oh, my bad. It's a pentagon.
It's a pentagon. The other one is a star. Yeah, so the diagonals of a pentagon create another pentagon, and they do so infinitely. It's kind of there's some really cool digital art based on stuff like that. But that's not the point here. The point is to label them. Okay. Now, are these red things lines or line segments?
Those are line segments.
They're line segments. So like if we label them in some sort of reasonable order, it's like AC and then AD.
And then like AE. E?
So what AE is not a diagonal because they're adjacent.
Oh, so then am I allowed to start with stuff other than A?
Yes. So like that's what I would tell you to do is I would move to B. You've got to do this sort of in an orderly fashion. B touches D, B touches E,
E.
and then you go to C and do the same thing. But notice you already have CA. Okay, so we didn't talk about that, but CA is the same as AC.
Oh yeah, because it's going to the same
Right.
spot.
Yes, but rays, it's not the same. Ray CA wouldn't be the same as ray AC. It depends. Like the what you have to think about is, does the order matter? And it does not when you're talking about a line segment. It only matters with a ray. But there's another one, C to E, which is not on our list. Right there.
Mm-hmm. D, E. And then C to E.
And then you got D to B, but you already have that.
Yeah. And then I guess D to A.
But you already have that.
Yeah. So then what I put
These are the only five.
lines because they have an end.
Say that one more time.
So am I gonna have any arrows on the line above the letters or
No. No, because they're segments. Segments are just a it's fixed on both sides.
All right. Okay, that makes more sense.
Okay. All right. I'm just looking at some other stuff here, trying to figure out. All right. So the next kind of thing we'll look at here is the instructions here say to give a possible name for each polygon.
Mm-hmm.
So this is a square. You know that this is a square. It does not matter what letter you start at. So you could go B, C, O, L. You could go this way. Okay. You could start at O and go the other way. Like you could literally start anywhere. Now, sometimes you put a square in front. If you don't know what it is, you can call it a quadrilateral. You get into naming conventions, I guess, later on in the course, but not right away. Yeah.
All right. So then with something like that, would the problem just be like just name the stuff in order and put the line over it, or there'd be no line?
There's no line. There's no line over it. It's like sometimes you put this symbol right there in front.
Mm-hmm.
Okay, now let me ask you some questions. Have you? Well, of course you probably haven't. So have you been using a compass and a protractor yet?
No, but I've heard the name.
Okay, I don't think you're there, but like I'm looking at a question like this one. Let me snip it in here. It says an acute angle DOG with a measure of 45 degrees. So you've got the one that looks like this.
Mm-hmm.
All right, so you can actually do this two ways. You can either do it with one or the other, but I guess this is a protractor. With a protractor, you would just sort of say, oh yeah, it's right there. And here's what you have with an angle that's very important. The middle letter is always the vertex. Okay, so the O goes there. Now the D and the G, actually, and you got to have the arrows, you actually could have them flipped. It could be D, O, G, G, O, D. Okay. Those are the same. So with the angles, it actually doesn't matter, but that middle letter is important.
Okay, so G-O-D, D-O-G. So it has to just always be, the middle letter has to be the one.
It has to be the vertex.
So what if there's 4 letters in it, like A, B, C,
They're
D?
not for an angle. An angle is always
3.
3. So like what I'd like you to do is try to draw this on your page, paper, whatever notes,
Uh-huh.
and we'll see if we can agree on this.
Okay.
I'm gonna just look through your pictures one more time and see what else I can.
All right, I think I got it.
Okay, so the main thing, and it depends on which orientation. If you make there's lots of right angles, but the T has to be right there, and you
Mhm.
generally need this symbol. That's the universal
Like 90 degrees.
90 degree. You've got to have the arrows, and you've got to have the other points.
Mhm.
Okay, so if you had E up here or down here, or if you rotated it, or if you if you had the angle going the other way, it really there's lots of options. So actually
Mhm.
grading this is more difficult for the instructors than normal, because
There's so many
there's
choices.
yeah, especially when you got to draw stuff.
I have a question. So I made that a triangle. Would that be wrong, or is that still fine? Because
Uh, well, so if you here's where it's wrong. If you did this, okay, but did not add these, then it's definitely wrong. You've got to have the arrows.
Oh,
Okay, but if you wanted to call this R and T and E, that's great. You got to have the arrows. So
okay.
they're like really particular in
So
this
then
class.
with showing, so with that it's just infinite because there's no lines or anything on the RTE.
So angles go on forever.
Okay. Angles go on forever.
Yeah.
Angles go on forever.
So the this is where we can talk about something else for a moment here. So let's say you have this right here, these angles. If you swing an arc here and you swing an arc here, they are different in length, but the angle is exactly the same because it's always this central angle here. But what changes is the length. Like if you were to walk from A to B, that's obviously longer than say from C to D. Okay.
Mm-hmm.
But the measure of angle COD is congruent to the measure of angle AOB.
Um,
Here's what an angle is, and this is probably what's not clear. An angle is a rotation.
all right. And does that mean like something that can be rotated or something that already is rotated?
It's like it's a nut. So here's what you're used to. And there's a lot here to digest. You're used to X and Y. You're used to like, okay, I move right and then left. But there are other coordinate systems where you do the following. You rotate and then walk. And you might like try to visualize you're pointing this direction. Like imagine you're standing up and you're looking in some direction, and then I rotate you some amount and then you walk, and that gets you to here.
Oh,
Can I also get you to there by saying go 8 right and 6 up?
okay.
So you could get there by going 8 right and 6 up, or I can rotate you and then say walk, in this case 10.
All right.
And this is actually a really fun exercise to do, which I mean, they probably aren't doing, but
Yeah.
it's so angles are the rotation. They're how much you are spinning before you walk in a certain direction.
Mhm. So, with like, for example, with that one above, the so going from like C to D and then A to B, I'm pretty sure, then you're going the same like
The
angle
rotation is the same, but the like distance you walk is obviously getting,
longer.
yes.
So does that mean the angle's like the curvature of the line segment inside that?
The angle is the amount of rotation from one ray to another.
So it has the same rotation,
Yes.
even though it has
Yes.
a different length.
Yes.
Okay. All right, that makes more sense. Angle.
Yeah. I mean, it's all really interesting to me, this sort of this rotation stuff, but they won't present it this way.
Mhm.
We kind of skipped over this, uh, but I don't know if you've gotten to this at this point. If you use this letter M, it means measure of. Okay, so let me try to explain that and give you an example here. So this is your pizza slice. This is 30 degrees. This is A, this is B, and this is C. Okay, so the measure of angle CAB is 30 degrees.
CAB is 30 degrees. Okay.
Okay, if I just talk about angle CAB, I'm referring to the angle CAB. I'm not referring to its measure.
Okay. And that whole drawing is technically an angle, sort of.
No, well, I call it a pizza slice, but it's an angle. It's actually part of a circle. It's actually called a sector.
Okay. It's like a
Okay.
slice of a pie
But what
or
I'm trying to show you is there's a difference when someone asks you for the measure of an angle, they're asking for a number.
something.
If they're asking for angle CAB, they're asking you to draw it.
Okay.
Now, this next part's going to occur later in the course, but I think it's an important thing to bring up here. If I ask you for the measure of arc CB, here's what I'm asking for. I'm asking for the walking distance from C to B. Like imagine you walking around a lake, go from C to B. There's some distance there.
Uh-huh.
But if I'm just asking about CB, I'm literally just referring to this piece here, but not the distance. So if this little m means measure of, it means give me a number.
Okay. So the M, I mean the, sorry, which is it, the CB or the M you said?
The m is what means measure of.
Okay. M is,
And you'll start seeing more of that. Okay, so like in the context of what you're going to see, it might say the measure of AB, line segment AB is 4, and I'm gonna just do it to say 4 squares. Okay, so four lines. So there's A and there's B.
there's A.
Yeah, so when they ask you for the measure of something, like let's say this was given, and they said, what's the measure of line segment AB? You would want to say it's 4, squares, or 4 whatever units, like centimeters, inches, so on.
Okay. So it's moving over 4.
Yeah.
And then it's a line segment that's not moving on for infinity.
It's fixed, yeah, fixed at each point. Oh, so at some point you talked about midpoints, maybe? Is that true?
That sounds familiar.
Okay, so this is kind of your first question for you to think about is, does every line segment have exactly one midpoint?
No. Yeah.
So here's the answer is, if it's no, you have to give me a counterexample. And that's okay. If it's no, then it's no, but you have to then come up with a counterexample. So your counterexample would be a line segment with 0 or 2 midpoints.
Mm-hmm. So then,
Like to me, the midpoint of AB is right there. And it's always right there.
uh-huh. So the midpoint's just the point in the middle of whatever.
Exactly.
Is that applied for just line segments or lines?
Yes. Because if I ask you the same question now, but I change it to a line, does every line line have exactly one midpoint?
I guess you wouldn't know because it goes on forever, right?
That's exactly right. You actually don't have any midpoints because it goes on forever. And the like, let's say you and your friend are standing some distance apart, and like maybe you're like, oh, that's the midpoint. But a line, in the case of a line, it's like he's moving, you're moving, so you never can figure out where the middle exactly is.
Yeah.
So this one would be a no. So here's another one for you to think about. Is every triangle a right triangle?
No.
No. Okay, so I agree. Can you draw a counterexample? Meaning, can you
Um,
draw a triangle that is not a right triangle?
yeah, I can.
Okay, go ahead and draw. There's actually two I'd be interested in seeing. See what you can come up with.
All right. Boom. Oh, draw two triangles.
Yeah, and I'm gonna answer what I'm thinking of is what's called an acute and an obtuse triangle.
Mm-hmm. Did we go over that in algebra? Those sound familiar.
Not really. I'll just draw them for you here. So an acute, all the angles are less than 90, and obtuse has one bigger than 90. These are obviously not right triangles.
All right. I think I drew an acute then.
That's fine. That's fine. You just have to find one counterexample.
Uh-huh.
Okay. Okay, so here's one. This is a tough one, I think. Sorry. I've got another. So what's interesting is you guys use the same textbook for all the geometry in your school, I think.
Yeah. Discovering geometry.
Yeah, and it's the same book that's been given every year. So I actually have some of these old pages. I want to just grab another one here. Um, here's a question. You didn't send me this, but I think this is a good one. If two different circles intersect, then they intersect at one and only one point. So it's either true and you hope that that's right, or it's false and you provide a counterexample.
Uh-huh.
So what you gotta be really careful of is when it says exactly or one and only one, you have to kind of go, it's either zero or more than one is what you're looking for. But because they intersect, you need to show something that intersects more than one time. Two circles that intersect more than one time.
Two different circles that intersect more. So they intersect more than one time.
Yes.
So am I gonna make a line segment inside the circle?
Nope, it's two circles. Circle one, circle two.
And then and they're completely like unique from each other, like they're not gonna touch each other.
Well, no, they have to. They have to intersect.
Okay, so then they
And this is
only one and only point. I mean, I guess where they hit the vertex, I'm not sure.
okay. Yeah, so this is where if you don't do much free drawing, you don't see that right away. That's a possibility, or that's a possibility where it's only one time.
Yeah.
So if I were teaching this, I would ask it differently. I would say, how many times does a line and a circle intersect?
How many times is a line in a circle?
So here's your line, here's your circle, and I'd want you to show all the possible cases.
Okay. And am I allowed to like rotate the line?
Yeah, absolutely, absolutely. You could. That's a line, any line you want. But I want to know the like. Let's just say, and I'll help out here. Let's because the answer space is really a table. It's how many times, and then it's a picture. So it's like one time, and then there's your
Mm-hmm.
or zero times.
That never touches it. So then
Like, so is there two times?
yeah.
What does that look like?
It could be in the center of the circle like that.
Right. Right. Now, is there, and this is where I think there's some really interesting questions. Now, think about a triangle and a circle. And you can choose any kind of triangle you want. How many different ways can they intersect?
Um, Probably like a dozen, if not more.
Okay, let's not do a dozen. Um,
Let's do like three.
well, I want you to go through it systematically. Like try to think about how do they intersect one time and then two times. I think it's hard. I think you'll see it's harder than you think. This is very much an exercise where you need to draw, a bunch of different circles and triangles until you figure out the possibilities.
All right. This actually leads me to a question. I'm not sure if this is like
Yeah, go jump in and ask. We're sort of free forming here.
there's like so we're doing this work and I can find the actual name of it if you can't think of what it is. But there was like a triangle inside of a circle, or it was a circle inside of a triangle.
That's right. So here, this is interesting. If you have a circle, a triangle can hit it 3 times like that.
Uh-huh.
Okay. Now let's say I wanted to hit 4 times. This is where it gets a little weird. Okay. You have to hit it, go past it, come back 1, 2, 3, 4 times. There's your 4 times.
Okay, that makes sense.
Okay.
So so it was kind of like that, but here, I'm gonna
So then you can also do the other one where it's inside.
yeah.
Actually, that's horrible. So there's actually there's a lot of circle triangle problems in social media. Let me draw you a triangle. So this is the common one. And it touches boom, boom, boom like that. It's drawn much better than that. That's the common one you see.
Okay, I found its name. It's called a zoid. Is that just like some random name in the textbook that doesn't matter?
Yeah, I saw that. That's really weird. This textbook is almost as old as I am. It's not a
Oh man.
it's not very modern, we'll say.
Okay, I didn't know if that was like an actual.
No,
like,
and see, they don't.
Then so I was
They are a thing in geometry, but it's
nothing used today, sort of.
it's pretty antiquated. I mean, we wouldn't. I mean, to be the people that. I mean, I'm looking at a website here from the Zoid company, and they're pretty dated.
Yeah.
So I think this is another kind of fun for me, like to talk to you about is like, well, now imagine a circle and a quadratic. Could a quadratic hit it? Say I could hit it 4 times. Quadratic could hit it 2 times. It could hit it not at all. How do you hit it 1 time? That's a more challenging problem. Either tangent, or it could actually come like this. So there's actually some really cool stuff with intersections of shapes that are pretty useful. So in computer aided design, when they're designing stuff, you generally start with something and then you cut it. And then that's how you get, that piece of it if you want it. And then maybe you bisect it and then you grab another thing, and you can do this in 3 dimensions. So if you were to take a piece of a block like this, actually this is drawn real well, but you imagine you wanted to cut through it. Well, you would take a circle and you just protrude it through the rest of the block.
Yeah.
So this is an application of this. If you and I were to start a tennis ball company, a circle that is rotated around its diameter produces a sphere. So that's some interesting stuff. If you look at the lines on a tennis ball or any of that, sometimes you can see some patterns there. A tennis racket. Hopefully, you're still doing some tennis.
Yeah.
It's got a if you look at the patterning on there, I mean, those are line segments now, not lines. They're sort of a hatch pattern, and then this comes down into the handle, obviously. So there's a lot of cool applications of geometry, but in terms of like somebody that designs one of these rackets, they start out with some sort of a shape, and then they sort of layer another shape onto it to get it to kind of form together. And a lot of it's based on geometry.
Yeah. Yeah, I guess a lot of stuff is based on geometry now that I think about it.
Yes.
Just about
The home you're in, the drawings just to build a home. Obviously, a lot goes into that. But all right. I'm flailing here a little bit. Is there any short questions you needed answered, or can we end the lesson here?
I guess one of my questions would be, what do you think, like because I think I might try and schedule another meeting with you like early for next week because I have a test on geometry
Okay.
week that I unfortunately found out just today, but
Let's focus on maybe sending the chapter reviews. If you got any other any other old exams, or if you can get your hands on anything.
all right, yeah, I mean, I guess I could try and ask some people who might have taken like this class around this time or something, like maybe ask if they still have anything.
You could ask a student if you have a friend in a class where they have the teacher there. That would also be a
Yeah,
good thing to do.
yeah, it's a good idea. But yeah, I
It,
guess basically I just want to make sure I get like back on track with this because this helped out a lot because like now I
okay.
can sort of understand like the concepts of geometry a lot more.
It,
Oh, okay,
it,
wait,
it will
actually,
get it will get better. Yeah. I mean,
yeah.
it's what were we gonna ask?
So when you have like, let's say a square, and in between, let's say like it's A, B, C, D. In between like the A and the B and the A and the C and the B and the D, there's like a line in the middle of the congruent line.
Okay, so like this right here.
Yeah, what does that exactly mean?
It means that the sides are congruent. So you can also have that in an equilateral triangle, all
Oh, so
sides
that's like
congruent.
the equivalent of like for just a normal line drawing the triangles. You just have.
Yes.
So do you
Now,
have to
in
make
a
a?
rectangle, this is important. In a rectangle, these two are congruent, and then you would use two lines to show that the other sides are congruent because they're not the same length.
Okay. So then if there's a shape or a shape with like even three different lengths, then I'd make like three little notches on it.
That's right. That's right. And you will see that. You will at some point. Because imagine, you've got one triangle, and then you got here's another triangle, congruent, 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 congruent.
All
Not
right.
not to scale, but let's just say they were drawn better.
Okay. And then like, so should I just normally make those little lines on a graph that's congruent, or not a graph, a shape
No,
that's congruent?
only you'll get to that later in the course with triangles, but no, not for now, or no for now.
Okay. All right. Thank you. That's one question that I was like
Yeah.
meant to ask way at the beginning.
Okay. All right, Zach, we do have to end here. Thank you so much for
Yeah. Sure.
scheduling, and I'd be happy to help you next week before your exam. Have a good night.
All right. Yeah. You too. See you, Matthew.
Okay, bye now.